everyone. Myself Dr. Vinayak, working as assistant professor from the Department of Agricultural Engineering, Aditya University. So last class we have discussed the different types of secondary tillage implements like disc harrow. Regarding the disc harrow, again they need to classify into three types: offset disc harrow, tandem disc harrow, like so single action disc harrow, double action disc harrow. We have explained last classes. So as well as we have discussed the different implements regarding the secondary tillage like pike tooth, spring tooth, disc harrow, assumed harrow. So ridgers, like we have discussed the up to last class. So today we are here we can explain the cultivators as well as some of the force acting on the tillage implement, as well as we can study the cost estimation of the tillage. So these are the learning outcomes from the today's lecture. So regarding the L1 secondary tillage implements like cultivators, today's class we can discuss, as well as force acting and cost estimation of the tillage operations. Okay, the first topic is the cultivator. So it is an implement used for the intercultural with laterally adjustable tines to work in between the crops. So before going to the in detail of the cultivators, regarding the cultivators we can classify into the two types. So first one is a rigid tine cultivator, one is a spring tine cultivator. You can see the image. So this one is a rigid tine cultivator, this one is a spring tine cultivator. Okay, so this one rigid tine, this one spring tine. Okay, so here in the rigid tine cultivator, these are the shank provided with the soil opening tool. Okay, so these are the shanks will be adjustable one provided. So based on our requirement we can adjust the these shanks. Okay, so here they can provide the, here we can see the springs were provided to connect the shank to frame. Okay, so before going to the in detail I will explain the different parts in the spring tine cultivator. Okay, so this one is a 3-point linkage frame, this one is a frame, this one is a shank. So the bottom of the shank we can provide the shovel also here. Okay, so these are the different components. So regarding the cultivators, two types, rigid tine and spring tine. So in the main difference in between the rigid and spring tine cultivator, in the spring tine cultivator we are provide the only springs to connect the shank to frame. So the rigid tine cultivator mostly used in coastal region farmers. So why? Because of the all the coastal region farmer soil contains sandy in nature. So in the soil having most of the part rocks and pebbles, in that situation we can go for the spring tine cultivator. So this spring can compression force will be act on this frame, so that the tillage tool may not be damaged. Okay, so in the place of springs, coming to the rigid tine, there is no spring was provided. Okay, these are the two types of cultivators. So it is mainly used for the intercultural with laterally adjustable tines. So these shanks also called as a tines. These are the tines. These tines are adjustable one. So based on the intercultural operations, we can adjust these tines. So this is also one tine, two tine. So this is another tine. This is another tine. Okay. So based on the our operation, we can change the. So based on the operational requirement, we can change the tine spacing in between the, suppose the tine spacing here we can maintain the 15 to 20 centimeter. If you required more space, by using these clamps we can adjust this tine to this section. So almost we can cover the 30 centimeter spacing in between the, if possible, sorry, if required the farmer, you can change the tine spacing also. Okay, next one is this cultivator stir the soil and break the clods. So last class we have discussed the regarding the tillage implement. So the entire secondary tillage operation they can use for the breaking of clods as well as creation of fine particle above the earth surface. Okay, next one is this, the tine is fitted on the frame of the cultivator comb the soil deeply in the field. Okay, So this tines was fixed on the, this one is a frame, no, this one is a frame, this tine was fixed to the frame. A cultivator performs functions in intermediate between the those plows and harrows. So this cultivator can perform, so in between the plow, like primary tillage, before going to secondary tillage, we can operate with the, once we can operate with the cultivators. So nowadays almost all the farmer, they did not go the both primary secondary like cultivator operations like. So most of the farmer, they nowadays they can go for the only rotary plow only. Okay, they can plow the land by using the rotary plow. So by using the cultivator, most of the farmer, they can use for intercultural operations like need to remove the weeds from the field, as well as for earthing operation also. Some of the farmer, they can use, they can go for the cultivators. Okay, so here we can see the cultivator operation in the field. Okay, so this one actually some groundnut field, I think so. So the gap between the row to row, the farmer initially they need to maintain. Okay, so like 10 centimeter 15 centimeter gap should be maintained before at the time. This gap should be decided at the time of sowing operation, no. Okay, so based on this gap, we can adjust these tines, as well as we can go for the intercultural operation in between the rows. So by using this cultivator only, we can remove the weeds in the in between the rows only. Okay, we cannot go for the in between the plants. Okay, so this one called as a row, the gap between the these two section called as a plant to plant spacing, P and P spacing, nothing but plant to plant spacing. This one is a row to row spacing. So the destruction of weeds is a primary function of the cultivator. Okay, for removing of weeds is a primary function of the cultivator. So this is the regarding the cultivators. So one thing we need to remember before going to the next topic. So regarding the cultivators, two types of cultivators are there, rigid tine and spring tine. So different components also there, frame, tines, shank, shovels. Okay, so as well as 3-point linkage system. This one is a 3-point linkage system. So both rigid and frame spring tine cultivator is using for same operation only. So that where we can use the rigid tine cultivator, we can mostly use for the sandy soils. The rigid spring tine cultivator mostly used in the where the field required in the stones and pebbles, like if the soil surface was hard in nature, we can go for the spring tine cultivator only. Okay, so next topic is a force acting upon tillage tool. Okay, so this one is a moldboard plow. Okay, this one is a moldboard plow. So this one is a side view of the moldboard plow. So by using the tractor, we can connect this 3-point linkage through 3-point linkage. So some of the force will be act on the tillage implement. Okay, so this force can be affected how much power was requirement. Okay, so this power requirement will be varies based on the number of tines or number of moldboard present in the MB plow. So as well as the depth of operation also affect on the power requirement of the particular tillage implement. Okay, if increase the depth of operation, simultaneously we can increase the power requirement also. Next one is a proper hitching and application of pulling force. Okay, so generally we have a 3-point linkage system. So top consider one link and bottom consider for 2 links. Okay, so I will draw one line diagram of the here top section, here bottom section. In the top section consider one link and bottom section consider 2 links. This one plus 1. Okay, so this is also bottom. Proper hitching, we can get the proper 3-point what to call 3-point linkage. We can get the 3-point linkage system through. Okay, so proper hitching or application of pulling force, it will be effect on the force requirement. Next one is a designing for adequate strength and rigidity. Okay, designing for adequate strength and rigidity to determine the best shape and adjustment of the tool. Okay, So suppose we can go for the generally the moldboard plow can be constructed with the fabricated with the cast iron as well as steel material. Some of the carbon percentage also included during the process of fabrication, during the process of preparing the moldboard plow. So how much type of material we need to use for the construction of the moldboard plow also very important. Okay, so that's why designing for adequate strength and rigidity. Okay, so how much strength it will have for ploughing operation. Okay, so by using the brittle material like what you call GI sheet like aluminum, by using this material we can construct the moldboard plow. So it cannot operate on within a per unit area of land only. Okay, cannot operate the particular one unit area only. Okay, so why? Because of the this material was very light in nature, so it cannot sustain that type of load. Okay, so that's why the strength of the implement is very important for the ploughing operation. As well as before going to the ploughing operation, we need to decide the what type of material having the what type of strength and rigidity. Next one is to determine the best shape and adjustment of tool. Okay, so while carry the tool from one place to another place, as well as while store the implement in a particular shed. Okay, so this shape are also very important. So as well as adjustment of tool, the tool should be easily adjustable. Okay, suppose we can dismantle the tool by using these nuts and bolts only. Okay, so again we can assembling the tools. Why? Because of this entire structure was fabricated or coupled with the bolt and nuts. Okay, so we can easily dismantling as well as assembling operation will be carried in the particular moldboard plow. So not only moldboard plow, each and every agricultural implement they can fitted with the adjustable one. Why? Because of the we cannot expect the field operations as well as so many farmers they can follow the different types of operations, farming methods also. Based on their requirement, we need to adjust the tools. Okay, that is also comes under this thing. Suppose here we can see the diagram. Okay, this one is a moldboard plow. So this one is a due to the weight of gravity. Okay, the entire weight can be acted on the soil surface. So here I am drawing the soil surface. This one is a soil surface. So this entire weight can be act on the soil surface. Some of the side draft also acted in this direction. So during the this one is a forward direction of the implement. This one is the forward direction. The vehicle should be moved in this direction. Okay. During the movement of the tractor, some draft force will be act on the in opposite direction like this. Okay. So this one is a point of contact or a resultant force will be act on the this point. Okay. So this one called as a R, where the all the forces will act on this point. So generally 3/4 from the land surface. Already I have explained in previous slides. So the force, the resultant force will be act on this point. It will be 3/4 from the landslide or 3/4 from the earth surface. Okay. So the vertical force can be act on top. The vertical force will be act due to the implement weight. The side force will be act from the soil surface. So at the time of movement of the prime mover, so the resultant force will be act in the opposite direction. So generally three main forces will be act on the agricultural implements. So first one is a gravity influence, the force of gravity action on the implement. Okay, so this one is a prime mover. So here we are attaching the one moldboard plow. Okay, MB plow. So without engaging and disengage the hydraulic lever, simply we can stand the in the ideal condition of the implement. So due to the some gravity force, the weight will be act on the earth surface, soil surface or earth surface. Okay, so this one called as a gravity influence force or gravity force act on the soil surface. So here we did not apply any type of hydraulic engagement or disengagement the levers. Simply we can stand the implement in a ideal condition. So, due to force of gravity, some of the force will be act on soil surface, that is this thing. Next one is the soil resistance, the force exerted by the soil on the implement. Okay. So, during the process of ploughing, so suppose this one is a moldboard plough now, so this one is a forward direction. During the forward direction of the implement, some of the force need to exerted by the soil on implement. Some of these during the process of forward direction, some amount of forces need to, so this one is a soil surface, the force exerted by the soil on implement. So, during the pulling operation of the moldboard plough, so some of the force will act on this moldboard, that is called as a soil resistance force. Okay. So, the implement should overcome the soil resistance force, so that the ploughing operation will be carried out. Okay. Next one is a prime mover interaction, the force between the implement and prime mover. So, this one is the implement. So, here moldboard nothing but one type of implement, this one is a prime mover. So, this is also prime mover. So, here prime mover nothing but tractor. So, this one is a prime mover, suppose we can link with the moldboard plough. Okay. The forces between the implement and prime mover, that is called as a prime mover interaction force. Okay. So, these three forces will be mainly important for the agricultural implements. First one is the gravity influence, soil resistance force. Next one is the prime mover interaction. Okay. Forces between the implement as well as prime mover. So, regarding the soil reaction forces, it subdivided into the two types, useful forces and parasitic forces. So, regarding the useful forces, the force must be overcome cutting, breaking and moving of soil. Okay. So, this one is a prime mover no. So, here we are connected the prime mover with the moldboard plough. Okay. This one is a moldboard plough. Okay. The force required cutting, breaking and moving the soil, that is called, that force called as a useful force. Tool must be overcome these three operations. Okay. This moldboard plough should be overcome these three operations, that force is called as a useful forces. Some parasitic forces also act on the tillage implement. So, that is friction and rolling resistance. Forces of friction and rolling resistance act on the stabilizing the surface such as landslide and sole of the plough. Forces of friction. So, during the process of the ploughing, some of the side force as well as soil frictional force will act on the implement. Okay. So, suppose we can suppose I am taking the, so this one is a moldboard plough no, this one is a rough sketch of moldboard plough. So, during the process of ploughing, the soil particle will be interact with this metal surface. Okay. These soil particles will interact with this metal surface. Due to the interaction, the friction will be generated. Okay. So, that is called as a parasitic force. Okay. As well as rolling resistance. Okay. So, this soil particle should roll like this. Again here the pulverization or inversion operation will be carried out. Okay. So, these two forces called as a parasitic force, this force called as a useful force. So, the useful force should be overcome cutting, breaking and moving the soil. Parasitic force nothing but the friction between the frictional force between the soil and tillage tool as well as rolling resistance where the soil particle need to move. Okay. Not only interacts with not only the soil particle interact on the moldboard flow, it is also interact with the landslide sole of the moldboard. Okay. So, these parasitic forces most of the cases we can most of the situations it will be required on rotary tillage implement. So, here most of the rotational force will be act on the soil surface. So, regarding the rotary tillage, the parasitic force was very important. So, here we can see the diagram, the force acting on the moldboard flow. So, already I have explained this one is a vertical force act on the moldboard flow, this one is a side draft act on this flow, this one. So, this one is a resultant force. So, this one is a line of pull. Okay. So, here line of pull also called as a virtual hitch point. Okay. So, where the point of contact suppose this moldboard flow can connected to the top link of the 3-point hitch as well as bottom link of the 3-point hitch. So, suppose we can engage this line and this line like this. Okay. So, where the point of contact both the top and bottom line of the 3-point hitching, that is called as a virtual hitch point. Virtual hitch point. Okay. So, here we can see the some of the forces acting on what you call moldboard flow. Here V nothing but vertical force. These are the resultant force. Okay. V R cos theta, cos phi and sin theta. Okay. So, next one is a side draft R cos theta and sin pi. So, here there is another resultant force will be acting in this direction R cos theta, and this one is a line of pull L equal to R cos theta and cos pi. Okay. So, the line of pull is perpendicular to the side draft. Suppose the angle between the line of pull to side draft is 90 degrees. So, as well as here the vertical force to line of pull here also 90 degrees. So, here some of the notation they have given P equal to pull exerted by the power of unit. Power of unit has component of all major plane associated with the it couple. Next one is R is the resultant force where R is the resultant force. All the forces act on tillage implement. Let us resolve the forces 3 components like L, S and V. Okay. So, this one is a point. This point is called as a resultant force where all the forces act on. This one is a vertical force, this one is a side draft, this one is a line of pull or line of pull. This one is a horizontal component of pull, that is a draft. Draft force will act on. So, V nothing but vertical component. It remove the load from front wheel of the tractor and effect on the tractive ability of the tractor. S is a side draft or side force act on the implement. Okay. So, here we can see some of the equations regarding the forces acting on tillage implement. So, V equal to vertical force, this one is a vertical force R sin theta and cos pi, and S is a side draft R cos theta and sin pi. So, where theta is the angle of inclination of resultant in a vertical as well as horizontal plane. Okay. So, this one is a theta, this one is a theta. So, next one is a pi nothing but resultant angle of inclination resultant as well as transverse plane with the horizontal. Okay. So, the angle between these two section V with L as well as V with R, that is a pi, this one is a pi. Okay. So, the theta nothing but angle of inclination resultant force with the horizontal plane, vertical plane with horizontal, theta nothing but inclination resultant in transverse plane with the horizontal. Okay. So, P nothing but sum of L square plus R square, okay, L square plus V square. So here we can given the equation. So L nothing but R square cos square theta. Simply we can square this one, okay, so that we can get the P equal to R cos theta, okay. So here R nothing but resultant force and theta nothing but angle of inclination of resultant in vertical plane with the horizontal, okay. Simply we can go through these equations. So next one is the cost estimation of the tillage implements. So here we can see the one numerical regarding to this. A farmer purchased a tractor of 25 kilowatt power at a total cost of 3 lakhs and 3 bottom plow was 30 centimeter bottom, 3 bottom 30 centimeter bottom width at the rupees 12,000 only. The fuel consumption of the tractor was 6 liter per hour. The ploughing was ploughing speed is 5 kilometer per hour. Calculate the area ploughed per hour as well as determine the cost of ploughing per hectare. Make the necessary assumption for any, okay. So here they can we need to calculate the field capacity, okay, that is hectare per hour, okay. So the already we know the what is the field capacity of formula W into S by 10, okay. So this one is a width of implement, this one is a speed, okay. So by the conversion of width here already they can give the 30 into 3. So here 30 nothing but spacing between the two plows and 3 is a 3 bottom plow, okay. The spacing between the, suppose here consists of a, this one is a 3 bottom plow, 3 bottoms are there, the spacing between the 3 bottoms is 30 centimeter like that, okay. So simply we need to multiply 30 into 3, okay. So 5 into 1000 we need to convert kilometer per hour into the meter per second. So that's why they was taken the 5 into 1000. So again we need to convert this meter square into the hectares, that's why multiply with the 10,000. So that we can get the 0.45 hectare, okay. So next one is a for tractor, we need to calculate the cost of operation for both the tractor as well as implement. For tractor they have given the, we need to calculate the fixed cost, no. So for the fixed cost we need to define the depreciation, interest as well as tax and insurances. So regarding the depreciation, the formula is C minus S divided by L into H. So initial cost of the machine is 3 lakhs. So salvage value nothing but 10% of initial investment, okay. So that is 3 lakhs divided by 10. So and lifespan of the tractor is 110 and annual working hour is 1000. So that we can get the rupees 27 per hectare per hour, okay. So per hour operation by using the tractor we can spend the 27 rupees. So regarding the interest rate also, this one is the formula for interest rate, C plus S divided by 2 into I by H. So here already we know the initial investment, salvage value, interest rate. By using this formula we can calculate the interest rate also, okay. Next one is the, so 16 rupees we can get. Next one is the repair and maintenance of the 10 repair and maintenance of the cost, we need to assume the 10% of the initial investment, so that we can get the 30 rupees per hour. Housing and taxes was considered 3% of initial investment, that is go for the 9 rupees. So already I have explained this calculation in unit 1. So you can if you have any doubt we can see we can refer that lecture. So regarding the operational cost, already they are mentioned the fuel consumption. So the we have here we can assume the fuel consumption rate, what you call fuel rate 24 rupees per liter. So fuel consumption is 24 into 6 liter was consumed per hour. So 24 into 6 we can get this one. Lubrication cost 30% of fuel cost, okay. So the fuel cost per hour we can per hour we need to spend 144 rupees. So 144 into 30% we can get this one. wages rupees 150 per day. Okay, per day 8 hours operating hours. So wages 150 we are giving no. So per day how many operating hours is there? 8 hours. 150 divided by 8 we can get this thing. So we can add this entire calculation so that we can get the 282.45 rupees. So up to now we have calculated the for tractor only. Again we need to calculate for implement. So already they are mentioned 12,000 rupees was required for purchase the one plow. Okay. Again we need to calculate this thing depreciation. So the depreciation cost was 3.6 rupees per hour and interest rate is 2.20 rupees per hour. So repair and maintenance can get the 4 rupees per hour. House and initial cost is 0.40 rupees per hour. So insurance for the ploughing operation or as well as for plovers or implement they did not provide the insurance. So that the insurance was mentioned here nil. You can add the sum of fixed cost into 10.20 rupees per hour. Total fixed cost both tractor and implement. This one is a tractor, this one is a plough. So we can get the 298.65 rupees per hour. So area covered already we have calculated 0.45. Cost of ploughing you can get the 663 rupees 6 paisa rupees per hour. For operate the 1 hour of by using this both tractor as well as plough. So we need to pay the 663 rupees and 6 paisa. Okay. From this I conclude this lecture. This one is a summary of the today's lecture. So regarding cultivators we have explained as well as force acting on tillage implement and cost of operation of the tillage implement. Thank you.